Okay, let's now do the fun stuff, actually get the answers, now that we have practiced writing and setting up hypothesis tests. So now we're going to work on getting what's called p-values, and these are the very small decimals or percents that we're going to compare to our alpha values, and essentially being able to say whether or not our test is significant. All right, so let's talk about hypothesis testing using our software JASP. And again, I think you guys, by and large, are going to find this really easy. Hopefully this is the point where some of you with the statistics phobias start to say, oh, maybe this stuff's not so bad, because I can't tell you enough that gone are the days of formulas and z-tables and t-tables. All right, that is not a good application of statistics. Statistics is actually very fun and very applicable to being able to do research and test measures on children and adults and anyone that we're interested in. All right, so why hypothesis testing? And before I get into this, let me just say that again, this week is a little bit of a stepping stone to next week. Next week is arguably one of the most important weeks in the course, which is when we do 2-sample hypothesis testing. That is something that we do a ton in practice. In fact, I've been running 2-sample and 3+ sample tests over the past 2 weeks. It's very common. As far as 1-sample hypothesis testing goes, not as common because it is rare that we get that claim about the population. All right, but let's go through it, because once you get 1-sample hypothesis testing down, then adding more samples is not that difficult. All right, so why? All right, so how does it come about? Well, we have a single sample, all right, and so when I say a single sample, think of a collection of measures on a variable, all right? This could be a factor where we have averaged a bunch of items, or this could be a single item on a survey. And what we have is a claim about the population mean or the population proportion. All right, so what we want to do is we want to test if this claim is true or not. All right, so what do we mean by that? So this is where think about statistics as distributions. So we have a population mean, okay, and let's do something easy. Let's do IQ score, because this is something that we're all qualitatively familiar with. We know what IQ scores mean, and so the average IQ score is 100. Okay, that doesn't mean that your IQ is 100 or my IQ is 100. It just means that the average of the population is 100. And around that 100, we have a normal distribution of IQ scores. And in that distribution, we have people with IQ scores of 70 and 120 and 160 and 68. All right, so because it is normally distributed, we have likelihoods of seeing IQ scores. And so we know, because again, we qualitatively understand this, that an IQ score of 160 or even higher is very rare. All right, and so we get a sample of, let's say we have a sample of, let's just keep the numbers easy. We have a sample of 50 college students, and their average IQ score is 120. Okay, so we now have a distribution of average IQ scores of 50 college students. Okay, there's a distribution, and 50 college students may have an average IQ of 100 or 110. We don't really know. There's a distribution there. All right, and we know by the central limit theorem that the population average IQ score, so mu, of samples of 50 college students is 100. All right, and so we would want to test to see if maybe the mean, maybe we have an alternative of, or a null of maybe the mean is equal to 110, all right? Or let's just say 100. We want to test if the mean IQ, mu, is 100. But we have this sample with a sample mean where the sample mean is 120, all right? So the question becomes, is it likely that that 120 is in a distribution centered at 100? Okay, and if it's not likely, meaning usually less than 5% or less than 2.5% or less than 1%, if it is unlikely by our definition of unlikely, that's alpha, then we reject the claim that the population mean is actually 100. Maybe it's something different, because we would not have gotten this random sample with an average IQ of 120 if mu is actually 100. All right, and I know what I just said is complicated. That may be something where you want to rewind and listen to it a few times. Maybe draw a picture as I'm talking it out. But there tends to be, I don't want you to think that there is magic involved in the rejecting and failing to reject process, okay? Because there's no magic. It is bona fide math. All right, so we have this claim about the population mean. We want to test if it's true. All right, so in the real world, what do? Okay, we have a claim percent of peer victimization in middle schools. We want to see if that claim that I think it's 25% of kids are victims of bullying, we want to see if that's true. So what do? We go get a sample. All right, so we'd go to a middle school and get a random sample of middle schoolers. All right, we'd calculate the sample mean or sample proportion. So here we would get the sample proportion of who claims being a victim of bullying and who doesn't. And we compare this statistic to the population parameter. So we would compare our sample proportion, whatever we find, to the population parameter of 25%. All right, so how do we actually conduct a hypothesis test? All right, well, you know at this point that it all starts with writing the null and alternative hypotheses and stating the claim. All right, we're going to import our data into JASP, and we're going to use JASP to calculate the p-value. All right, and then what do we do with this p-value is we compare it to alpha to make a statistical decision. Okay, and so this is where if the p-value is less than alpha, we reject the null, and if the p-value is greater than alpha, we fail to reject the null. And alpha, students start asking me, okay, what's alpha for this problem? What's alpha? Because I'll be honest, sometimes I forget to tell you what alpha is, because alpha is not a real-world practice. We do tend to use alpha of 5% as a cutoff, but in the real world, we like to see p-values as small as possible. And in an ideal world, we get p-values of less than 0.001%, okay? All right, and so then we write the conclusion in terms of the claim, all right? And I'm gonna actually do some practice problems in this lecture, and then I've written you guys some homework problems where you get some more practice. Okay, writing the conclusion. All right, so we have a couple options here. The null can be the claim or the alternative can be the claim. All right, if the null is the claim and you reject the null, then essentially you're rejecting the claim, right? So we say there is enough evidence to reject the claim. However, if you fail to reject the null, then basically there's not enough evidence, right? And so we would say there is not enough evidence to reject the claim, all right? Conversely, if the alternative is the claim and you reject the null, all right, so think about this. You reject HO, so you are essentially accepting HA. HA is the claim, so essentially you're accepting or supporting the claim, right? And so we say there is enough evidence to support the claim. However, if we fail to reject the null, then basically all that's saying is there is not enough evidence to support the claim. All right, and I have this in a lot of different places. This just takes practice. If you're feeling overwhelmed, try to breathe through that, because it really does click. And I can't tell you enough that how many students, even if it doesn't completely click this week, next week when we're on 2 samples, I promise you it will click. All right, so let's do a few examples, and I'm gonna come out of this for a second. All right, so let's just read our problem here. A consumer group claims that students on average value success at a greater level than 5 on a 6-point Likert scale. Use the data to test this claim. All right, so first we would write our null and alternative. And what we read here is that mu, the average, all right, is at a level greater than 5. So we're reading mu greater than 5. That's our alternative, and that is the claim. All right, again, it's the alternative because there's no equals in there. It's a strict inequality. So we have mu greater than 5, which means our null is less than or equal to 5. All right, so we're good there. Now we want to actually find the p-value. All right, so let's go over to JASP. All right, and I'm walking you through these problems. I would not expect you to read this and know I'm referring to the variable success here. All right. All right, so let's do t-test 1 sample. All right, and let's talk a little bit about this. So we've got a list of all our variables, and we are interested in success. Okay, and you are going to leave student checked. This is the t-test. Okay, the test value. So this is the claim. All right, so what is our claim? And the claim is 5. All right, so the claim value is 5. All right, and for hypothesis, are we testing not equal to, so this is your alternative, not equal to, greater than, or less than. And again, let's look over here. We are testing greater than. So we go back over here and check greater than. We will do some assumption checks with normality, just not yet. The reason being I've given you a huge data set, and basically the data set's so large it's calling it normal. All right, we don't need to do location parameter, effect size. We will talk about next week. It becomes very important in two sample. You may want descriptives. You can always check descriptives if you want, but I am interested in just the p-value. All right, and so our p-value here is less than 0.001. All right, and so we'd go back over here. Our p-value is less than 0.001, so we reject alpha. All right, I mean, it is less than alpha, so we reject the null. All right, so what do we say here? We reject the null. The alternative is the claim. All right, so we are rejecting the null when the alternative is the claim. So there is enough evidence to support the claim. There is enough evidence to support the claim that students on average value success at a level greater than 5 on a 6-point Likert. So what this is saying is that this Likert scale went up to 6, and 6 was very important. And so the student is saying that it's more than somewhat important. All right, it's approaching very important. All right, let's consider living close to their parents. I mean, how many 12 to 18-year-olds want to live close to their parents forever? Okay, a consumer group claims that students on average value living close to their parents at a level greater than 4.25 on a 6-point Likert scale. Use the data to test this claim. All right, so 4.25 here would be just a hair above average, right? So basically our 3s and 4s capture our not strong opinions, somewhere in the middle of importance. And so being at 4.25, we're saying that on average, it's mildly important. Which is actually a really positive sign. But again, keep in mind, this is rural data, and we know that rural communities tend to be much more close-knit. All right, so we've got the average greater than 4.25, so that would be our alternative. So we would write the alternative as mu greater than 4.25. That is the claim because that's the one we're reading in the problem. And from there, we write our null, which is mu opposite to greater than, less than or equal to 4.25. All right, so we go over to JASP, and we take success away. And now we're interested in the parents. And so we move them over. And our test value now is 4.25. We're still interested in greater than. All right, and what we see is a p-value of 0.405. 0.405 is definitely greater than 0.05. All right, and if for some reason you have trouble comparing decimals, just change them to percents. All right, we do that math in a little bit of a different place in the brain. And so for some students, it's just easier to compare 40.5% to 5%, and then we know 40% is greater than 5%. All right, and the decision, of course, is to fail to reject the null. All right, so let's go back to our slide before. So now we've got the null, the alternative is the claim. We fail to reject the null. So now we would say there is not enough evidence to support. So there is not enough evidence to support the claim that students on average value living close to their parents at a level greater than 4.25. So bad news, parents. It's not greater than 4.25. And so it's probably closer to somewhere in the middle, those, neither important or unimportant, but somewhere floating in the middle that students actually value living close to their parents. All right. All right. So example number 3. All right. A consumer group claims that students on average disagree that people can do okay even if they drop out of school. This corresponds to a level less than 3 on a 6-point Likert. Use the data to test this claim. All right, so we have this claim that students on average disagree. Disagree numerically corresponds to 3. So our alternative here is mu less than 3. That's what we're reading and is the claim. All right, our null is the opposite of that, so mu greater than or equal to 3. All right, and so this is the dropout. All right, so, all right, this is a school value item. So if we go back, we removed parent and just scroll down, and we're looking for dropout. And there we go. See dropout towards the bottom. We're going to move that over. All right, we're interested in testing at a value of 3 and less than. And we see our p-value here of less than 0.001. All right, so we've got our p-value of less than 0.001. So what do? It is clearly less than alpha. We reject the null. All right, so there is enough evidence to support the claim that students on average disagree that people can do okay even if they drop out of school. All right, so this is wonderful news for school value and preventing dropout, right? All right, so this is just a few of the things you can do with some of the survey data that you're collecting when it comes to one sample hypothesis testing. So hopefully this is giving you some ideas. All right, and from here, what you want to do is do the homework practice problems. Anything that's not clicking, reach out to me. Let me explain it to you one-on-one, which we can do via email, text, or phone call, or FaceTime, whatever you want to do. And then you should be ready to do your first attempt of the quiz.